So let's use the example of the annual energy consumption to obtain the parameters associated with the trend component. So here is the expression of the beta 1 and beta 0. Let's calculate. Here we have the years. Here we have the explanatory variable, which are the number associated with each year, and here we have the energy consumption, which is, I guess, gigawatt hour. So multiplying xi by yi, we have this one multiplied by this one, and we need to sum it, sum from this to this, and then we have this part of the expression. And here we have the average value of the set of the data. So the average value multiplied by the sum of xi. Let me put it here. Sum from the first year to the last year. And then we have this part of the expression. Here we have xy squared, which is this part of the expression. So it is this one multiplied by this one, and we need to sum it. Okay. Here we have this part of the expression, x average, which is the average value of the x vector, and this should be multiplied by the sum of x multiplied by the sum of the x vector. Okay, so beta 1 is this one minus this part, which is this one, okay, divided by this one, which is this part, minus this one. Okay, so this is the value of beta 0, beta 1, and the beta 0 will be the average of data multiplied minus beta 1 multiplied by the average of x, the average of x of the x vector. Okay, so now we can compute the model. We can compute the model by using these parameters, which will be beta 1 multiplied by x plus beta 0. Okay, and we need to use F4 to keep the parameters the same, and then oops, we don't have. Let me change it. It's not F4. This is F4. Now we have the model associated with this data. Let's see graphically how it fits. Here we have the original data. So I'm going to incorporate the data obtained by the model. Here we have the explanatory variables, and here we have the set of the data obtained. As you can see here, let me improve the visualization. Let's start from this point. Now we can see that the model fits well with the set of the data. I'm going to change let me change this graph. How can I do this? Yes, better. So we can see here the model in this line in black obtained by these parameters, and in blue we have the set of the data used to estimate the model. The red are the points that should be compared with the data of the model, with the original data. Okay? So it could be easily obtained by the Excel. It's not needed to compute the beta 0 and beta 1 here in Excel. We can obtain it. This is the equation associated to this function, and the R² gives us an idea of the how well the model fits in this case. So as you can see, the Excel provides the same result of the parameters. Here we have beta 0, here we have beta 1, and the R² is 97% approximately, and it means that, to explain well, the variation of the X value the variation of the energy consumption is well explained by the variation of the X values. This is basically what is which is saying by the R² value. Okay, in the next class we will talk about the seasonality and how can we combine both the seasonality and the trend component to obtain a model for data with in a smaller scale, such as monthly or weekly, etc. Okay, see you in the next class.